Hello, hello, Shagathanoon here. Welcome back to another Rust coding stream here on the 14th of December 2022, local time 1628. And last time we did the maze algorithm, which I already launched this, so let me relaunch it. We can look at a maze generate. I'm not going to run through one of these because it actually takes quite a while to navigate, but it spawns enemies, it spawns items and stuff, and it works as you would expect. So there we go. We had a quick maze generate. And today, guess we're not going to waste much time getting to it, but we have the Diffusion-Limited Aggregation. So this is one I don't really have much experience with, but seems like it's going to be related to Drunken Walk. And I think I skimmed it last time, and I remember seeing, okay, yeah, we recognize some of this. So let's go ahead and get started. Diffusion-Limited Aggregation, DLA, is a fancy name for a constrained form of the Drunken Walk. It makes organic-looking maps with more of an emphasis on a central area and arms coming out of it. With some tricks, it can be made to look quite alien or quite real. See this excellent article on Rogue Basin. Okay. Random walkers move diagonally and orthogonally. We get something like this. Here's one produced by walkers who can only move orthogonally. I do like this one with the diagonal movements. Block aggregation. Interesting, okay. Corridors only. Diagonal corridors only if you want to be evil. Probably best used with permissive field of view. We have pseudocode. HTML. they put JavaScript, that's why. In case you're building it in JavaScript, got it. For a browser. Okay, let's get back to the page here then. And we're gonna do the scaffolding. So we're gonna need DLA.rs and we're gonna need a DLA builder. So let's get right over to here and we're just gonna do mod DLA. And this is gonna be DLA builder. And now here I'm gonna make DLA.rs. And now everything is happy for the most part. Let me scooch over my browser here with the tutorial to the other monitor. So we're gonna go into DLA.rs. We're gonna have to make all the fun stuff there. There's a few algorithm variants that can produce different map styles, so we'll introduce some enumerations as well. So before we actually make our builder, okay, yeah, we'll actually type these out because it's going to be a little bit different than our normal scaffolding. Oh, no, we're going to take the same scaffolding. All right, then I'm just going to switch over to the previous chapter and I'm going to copy the scaffolding. And then we'll change some names around. Because at this point, we've done plenty of the same stuff here, right? So instead of maze builder, it's going to be DLA builder. I think that's how I spelled it, how it was spelled here. Correct. Yes, perfect. Also, let me double check. Okay, good. I am unmuted. Had a moment of panic there, but we're good now. Okay. So we are going to need a couple extra things here. So one of them is going to be, well, there's going to be two enums. Partial EQ, copy, clone. Now I think Clippy might get a little bit mad if we're doing partial and not regular EQ, if it's possible. We're gonna make a public enum, DLA algorithm. It's gonna be walk inwards, walk outwards, central attractor. And pub enum. Symmetry, it's going to be none. Horizontal, vertical, both. And yeah, we're getting a lot of warnings because we're not using anything yet, but that's fine. And it is complaining about should we also do EQ. I'll do EQ. I don't see why not to. Okay. So there we have this little first piece that we added on after we put the scaffolding in. And that's going to, of course, allow us different algorithms and how the drunkards move, basically, and then enforce some rules of symmetry. So I guess we'll take the central vertical and horizontal axes and mirror things around them. That actually doesn't sound too bad, but we'll see how it gets implemented here. There may be some interesting ways that we do it. I don't know. I haven't read this yet. So we have map, starting position, depth, history, and noise areas. So now we're going to need a few extra things. We're going to need the DLA algorithm, the brush size, DLA symmetry, and floor percent, which I'm thinking is going to be how much of the floor do we want to hollow out. So we'll click back over to the text here, and it says this should be pretty self-explanatory by now if you've been through the other chapters. We're supporting 3 algorithms, walk inwards, outwards, and a central attractor, and we'll cover these in detail shortly. We've added symmetry, which can be either non-horizontal, horizontal, vertical, or both. Symmetry can be used to make some beautiful results with this algorithm, and we'll cover that later in the article. We've also added brush size, which specifies how many tiles, floor tiles we paint onto the map in one go. We'll look at this at the end of the chapter. And we've included floor percent from the Drunkard's Walk chapter. Yeah, and we saw that there. How long do they walk until X percent of the map is uncovered, is floor. And now we're going to do our new function here. So, yeah, it's a little bit unhappy right now. So let's go ahead and do algorithm. Whoops. I wanted to put it after U. Doesn't really matter, but still. Now we're just hard coding it to walk inwards. And I think from skimming this the other day, what we're going to do is make multiple constructors depending on what algorithm we want to use. So rather than passing in an algorithm, we say DLA builder walk inwards or whatever it's going to be. So I think that's how we're going to end up doing it. But we'll probably be refactoring this as we go. I just remembered, I think I want to do 2 chapters today because the next one's a refactor. We'll see how long this goes. I got started pretty early today, but I also don't want to go too late. I want to be able to wrap things up at a reasonable pace. You know, more time to myself, personal time, you know, all that good stuff. Time to get relax, get ready for bed, try to get some decent sleep. You know how it all goes, right? All right, so we'll make some, yeah, and the tutorial says we'll make some type constructors once we've mastered the algorithms and their variants. So we're going to walk inwards. The most basic form of diffusion-limited aggregation works like this. Dig a seed area around your central starting point. While the number of floor tiles is less than your desired total, select a starting point at random for your digger. Use the Drunkard's Walk algorithm to move randomly. If the digger hits a floor tile, then the previous tile they were in also becomes a floor, and the digger stops. Okay. Very simple and not too hard to implement. So let's take a look at it. So we have this build function here, and I don't know. Yeah, I don't know how much exactly is going to remain the same. I think, yeah, I think it's pretty straightforward though. Let's try removing, I don't know, about that much. We make an RNG. We say carve a starting seed. We do starting position. And what are these going to be? This is going to be, also let's get rid of that map entry there. This is going to be self.map.width over 2. And height over 2. That's our starting position. And we'll get that starting position back out and create a start index from it with our map XY index. We'll take a snapshot. We'll delete this one. I didn't realize we already had it there. All right, now we'll do a bunch of lines that start out like this. Okay, that'll get us the starting bits in here. We can work with it. So we'll set it to floor. Actually, we could have done a multi-line cursor because they all get set to floor. This is our starting seed. It's just like a starting area to work with. And it looks like we're just getting the areas around the start. So we went one to the left, one to the right, one to the top, one to the bottom, and the actual starting index. So a little bit of a little plus sign there in the middle. And all those are now floors. That's our starting area. Now I'm guessing if this is a seed, we could actually make random seeds as well, and that would be able to produce very different results. And I don't know if we're going to do anything like that, but since the algorithm, based on the description that we already read, seems to rely a lot on finding a floor, then we will maybe look into changing up what the floors are. But, I mean, the point of the random number generator, it's already going to be very, very random anyway. Hey there, Tusk. How's it going? How are you? So now we're going to do random walker. So we're going to get our total tiles, which is just width and height. And we're going to get our percentage of how many tiles we want. So floor percent times total tiles as F32. And then we're going to cast that to a U size. There we go. And then we're going to keep track of the floor tile count so we can compare to desired floor tiles. So we're going to use a little filter here, iterate over the map, filter, and just get everything that's a floor and grab a count. That's going to get us the starting count. We could pretty much just hard code the starting count because this is not going to be, this is just initializing, so we pretty much could hard code it in as 5. But we'll go with the way the example has it lined up here. And now that we have our count, we can start our loop. Now some of this is going to be familiar from the Drunkard's Walk algorithm from a couple chapters ago. Similar feel here. I think we did the exact same filter and everything. The exact same iter filter count structure there. Paradigm, I don't know. There's a better word. Construct, there we go. So while the floor tile count is less than the desired floor tiles, then we do a bunch of stuff. So we match on the algorithm, and what we're doing now is we're only working on one at a time. So we're going to start with DLA algorithm walk inwards. And then in any other case, we're going to do nothing. Yeah, Clippy's going to be a little bit mad about this, and hopefully we can not worry too much about that. It might be a little bit annoying, but well, it is what it is. Let me also close that so we get more on the screen here. Because yeah, it's like you seem to be trying to use match for an equality check. Now that's just a little, we can suppress it if we want, but the purpose of that is if you're checking against multiple variants, but you're ignoring most of them, then it does make sense to, if you're ignoring all but one, it basically is an equality. But we're going to be changing that here in a bit, so no worries there. So we're going to do a roll dice. It's going to be a 1d self.map.width minus 3 plus 1. And same thing for y, basically. A 1d self.map.height minus 3 plus 1. Okay. And that gets us our starting point for the digger. And we'll store the previous x and y values of that as we're going to be mutating them in a moment. So we'll do the XY index. We love doing that. And we'll convert the x and y values that we have into a U size that we can actually index into our map tiles. And now, while self.map.tiles, and we'll get the digger index tile equals a wall. So we're doing, we should be able to remove this initialization here. Yeah, because we're assigning and we're never using it. In this first iteration, it's not going to matter. So we'll probably address that in a little bit. I want to make some progress here. How do I do this? Allow absurd extreme comparisons. Allow, what is it called? Single match. Let's try to suppress that. Okay, that's better. That'll make things a little bit cleaner, and I can remove that once we are in a better position. Okay, so we're going to, in this loop, set our previous x and y to our current values for the digger, and then we're going to let stagger direction equal rng.rollDice, and it's going to be a 1d4 because there's only 4 directions it can go. We're not doing diagonal, we're doing orthogonal movements. And we're going to match on the stagger direction. And some basic checks here on the different directions that we can go. 3 and 4, boom, just like that. So if x is greater than 2, then go left. So then we're also going to need if x is less than self.map.width minus 2, then we want to go plus equal 1. And we need to do the same thing for y. So the first y for 3 should be identical. If y is greater than 2, then we take 1 away from it. And if y is less than self.map.height minus 2, then we add 1 to it. So that gets us our stagger direction. And we, oh, right, not 4. I got carried away. I was like, wait a minute. Yeah, we just blanket that because we know we trust the RNG. So there we have our stagger direction. So after that match, we've moved the digger. So we'll set the index. And there we go. Now, next, we'll do the self.paint, which we don't quite have yet. But that's happening after this, right, because how the algorithm works is once it finds a wall, or no, once it finds a floor, then it modifies the previous tile, but it's using a brush. That's why we call it paint, because it's affecting more than one tile at a time, depending on the brush size. Okay, so we're gonna need to make this paint here in a moment. And it's kind of mad because of that. So the tutorial text says the only new thing here is the call to paint. Actually, yeah, it pretty much is very similar to what we did before. We'll be extending it later to handle brush sizes, but here's a temporary implementation. So we'll just plop it right in here. It takes mutable reference to self. And it takes X and Y. We'll just change it to X and Y. So we'll get that map index there, the XY index, and we'll do self.map.tiles. And we'll set it to floor. And we don't return anything. That placeholder was there. Okay, so that should mostly do the trick there for us. Variables in this condition are not mutated. Well, floor count, you are correct. That was not being listed here. And what I think is intended is that it's basically the same as the drunkard algorithm, the drunkard's walk. So if we take a look at that, yeah, there's like different amounts of diggers and stuff. We were keeping count of it, but basically the last thing we should do is the floor tile count. I don't think anything else really needs to be done right now, so hopefully that's fine. So we'll do right after this match. Yeah, right after this match, we'll try updating the floor tile count. And that should get us to a mostly working state for now. So let's take a look at, but not yet. We do need to not do the maze builder. We need to do the DLA, whoops. The DLA builder. And that should make things mostly happy. Let's see what happens, or if I missed something critical. Very possible that I missed something critical, because there's some... oh, no, that was very quick, though. We're not really taking a lot of snapshots. But we did generate a map. Let's take a look at the tutorial and see their generated map. And mine looks pretty much the same as theirs, which is cool. Our snapshots are not being taken appropriately. So let me add in, every time we paint, we'll do a self.take snapshot. And I think that'll do the trick. So before we go back, let's run this here. It's not shown where to do it in the tutorial, so we'll just reason about it for a moment. It's not that difficult. Oh yeah, this is a little bit too slow. Okay. Not every time we paint, but how about every time... yeah, how about that? That should be a little better. Hopefully. No, not really, because we're still running it every time. Oh, you know why? It's probably still keeping track of how many iterations. Was that in Drunkard? No, that was in the maze. If we did something, that's what it was. If did something. So we'll do that down here. I'll have to keep track of it. So comparing it, we only do it where we're actually setting a tile, basically. So... oh, but in this case, the paint... that's a little tough. I wish I could see exactly how they were doing it. The truth is, I don't really feel like... I don't really feel like going through and figuring out the exact way that they have it currently set up. Checking the other code, the completed version, would give a little bit of insight. Actually, I will... yeah, it's not going to be too bad. We're actually done with the walking inwards version, so I won't really be spoiling too much. Let me take a quick look. There's not a lot going on with the snapshots. There's one here. Self.take snapshot. Yeah, that's about it. We have the paint. Above that, we have the index. So let's see, previous X. Are we using those? Not complaining anymore that they're not assigned. Oh, because we may never hit that condition, of course. Yeah, then... I wonder why mine seems to be so much slower. It's a little odd. Just comparing to what they have, it's pretty much identical. We'll run it again real quick. Very, very slow, right? Wondering why we have this piece over here. What's creating that? I don't know. We'll keep digging into this a little bit as we go. We'll see it. No, see, yeah, something's missing. Something is different between what they have and what I have. If we see here, theirs does not have that little piece on the side. Actually, that was the wrong one. My bad. So this is walking inwards. Yeah, so mine has a little piece on the side, which is odd. So let me do a little bit of extra comparison here. Let's try to get into the same state. So we make our RNG, starting position, width and height over 2. Start index uses that X and Y, easy enough. We take a snapshot. Then we do start index, tile type floor, index -1, index +1, index minus map width, index plus map. Oh, I did height. That's a problem. I knew better, but I made a mistake. A lot of times you say width, you just think automatically you associate width and height. So let's take a look at that and see the difference now. Yeah, there we go. That's much better. It's still very slow, but it's much better. I'm not going to let that play out. Okay, so then we get total tiles, which is width and height. Desired floor tiles, which is floor percent times total tiles. Floor tile count, which is just iter filter for floor and do a count. That's easy. While floor tile count is less than desired. Then we go into the walk inwards here, and we get the X from width -3. Yep, +1. Y from height -3. That's good. And we do previous X and previous Y. We get the index. Perfect. While self.map.tiles, so we get the index. Is it a wall? So while it's a wall, then we get the previous X and Y. We pick a stagger direction. Make sure I did all those correctly. So if we are, basically the way I'll say this here, if the X is greater than 2, what I mean is if we're able to move left. If we're able to move left, then we will, right? Because we have the border of the map, so we can't move onto the border of the map. So x has to be greater than 2 for us to be able to move left. Or if we're able to move right, we'll move right. And then we do the same thing for the y values. If we're able to move up or down, we move those directions, depending on whether we rolled which direction we rolled. So that's straightforward enough. And then the digger index, we just set that again because we're going to keep using that to check as we go through here. Like basically we stagger and then we go through. And that should be good. Then we do the self.paint. It's very simple for now, but it's going to get better over time. This is just the initial version. Alrighty, so I think we're good. So now we see what it kind of looks like here. Pretty sped up from what we have right now, but pretty cool stuff. So now we're going to do walking outwards. So the second variant, reverse, is part of the process. So we'll dig a seed while the number of floor tiles is less than your desired total. We'll set the digger to the starting central location. We use the drunkard's walk to move randomly. If they hit a wall tile, then that tile becomes a floor and the digger stops. So instead of marching inwards, our brave diggers are marching outwards. Implementing this is quite simple. It looks very, very similar. So I'd like to compare and contrast the two once I have the walk outwards implemented. And now we're going to remove this thing because Clippy won't be mad anymore. So after this algorithm, we can do walk outwards. And I'm just going to copy some of the boilerplate here. I think we might use all of this. I'll double check. So the X, the Y, we're not using the previous ones anymore. Okay. We are using the index. So, and we're actually not doing a random spot. We're going from the center. So this is actually, yeah, this is a lot less similar than I thought. Starting position .x and starting position .y. Self.map.xy index, and yeah, there we go. Perfect. So now most of the rest of that will be similar, I think. So we'll use the index, and we'll while it's not a floor, we'll do the stagger direction, and I think it's going to be exactly the same. So much so that we'll even copy that bit. Alrighty, so yeah, let's stagger direction, just roll 1 to 4, and then x is greater than 2, x is less than map.width, y is greater than 2, y is less than map.height. Yeah, it's all the same, it's simple. And we do that good stuff, and then we paint. But it's not previous now, it's just digger X and Y. Okay. So if we adjust the constructor to use it now, and we run it, it's going to be pretty slow. We'll take a slow look at it. So the difference that was happening before, it's a little hard to tell, but what was happening before is when we were walking inwards, they were actually starting like anywhere on the map, and they would walk until they got, well, you won't, they're not walking to the center. They're staggering around. They're randomly walking. But then once they hit a floor tile, they open up the next adjacent tile, or they open up the tile that they were just on. So this one works a little different in that we know we're starting on the floor because we're starting from the center. So now it moves outward until it hits a wall, and then it modifies the wall. So that's the only real difference. All right, so we're gonna leave that there. I actually need to take a quick break. I'll be back in just a couple of minutes and we'll continue. All right, sorry about that, but we are back. Didn't really get to see the generation finish there, but it's very open. I think that's something that we kind of expected to a degree here. But I think as we change the brush sizes, it'll be less open, interestingly enough. Is that it? Is that the stairs? Cool. Alrighty. Well, let's go ahead and quit out of that. And let's take a look back at the tutorial now and continue on, because it's going quick. Good, it's perfect. Alright, so now we're going to do the central attractor. It's again very similar but slightly different. Instead of moving randomly, your particles path from a random point towards the middle. Okay, so we do like a Manhattan distance or something and just go straight. We just beeline. Well, we do line 2D, line algorithm. Okay, and then we just follow the line. So yeah, dig a seed. While the number of floor tiles is less, we'll select a starting point at random, plot a line to the center and keep it, and then traverse the line. If they hit a floor tile, then the previous tile also becomes a floor and the digger stops. It's relatively easy to implement, so let's do it. Spoilers. I gotta figure out why mine is generating so slow. I must be taking too many snapshots, but where? It looked like what they have. Kind of odd. Yeah, I didn't see them doing anything different. Whatever. There should only be 3 algorithms, so if I do this... Yeah, central attractor. I could have fixed it quicker than that. Alrighty. So now, we're going to get this boilerplate from here. So we are going to get random starting points and everything, just like before. We're going to get the previous values, and we're going to get the index. We're going to get an RL2K line 2D with an RLTK line algorithm. Brasenham, I don't know. RLTK point, and it's going to be the X and Y. And then we'll pop this down to a new line. All right, let that all format. And that's our path. So now we're going to follow that. So I don't know about this path is empty. I guess we're shortening it. It's a vector. The line is a vector of points, I see. Okay. So this is going to be pretty easy then. So we're getting the first thing on the line, which makes it critical what our start and end point was. If you were not following the line, like, how do I put it? If you weren't grabbing it from like directly from the start of the vector like this or something, it might not matter as much. But we're actually literally just following a series of points, so it does matter. We remove the first thing. And after this, we do our paint, and that's it. So pretty easy. We pick a random point, we start a line at that point, end it at the starting position, and then we loop through we loop through the points in the line, which is what this not path is empty is for. And for each point in the line, if it's a wall, we basically rip that point out of the line, we keep going, and we update the previous value. That's the important thing. And then once we find a floor, we use that previous value to paint that in or to paint we use the previous value, which was a wall, to then turn it into a floor. But again, the paint thing, it's going to be taking a brush and it's going to look different depending on how we brush it. We'll get to that soon though. And that's it. So we can adjust the constructor to use it, and we'll get, once again, very different results that look very similar. Oh no, someone's honking outside. You can kind of see how some of the lines seem to be spawning. They're producing a lot of very similar things. All right, I don't think we need to watch this whole thing. It's going to take quite a while. It's looking cool right now. We haven't got to this, almost said similarity, symmetry, but I know that's coming up as well. That might be next. I really need to figure out why theirs is so much faster. Whoops, wrong button. Alrighty, they're near each other. Implementing, it would be funny if I hit that button and it shows me for a moment, I'm just like naked or something. Like, no, that's why I turned the camera off. All right. So now we're going to implement symmetry now. Tiger, tiger burning bright in the forests of the night, what immortal hand or eye could frame thy fearful symmetry? Or symmetry. I've heard that before, William Blake. Definitely heard the name. It's been a while since I've done any of that stuff. Symmetry can transform a random map into something that looks designed, but quite alien. It often looks quite insectoid or reminiscent of a Space Invaders enemy. This can make for some fun-looking levels. Let's modify the paint function to handle symmetry. I was wondering how we were going to factor that in, because it's not hard to do per se, but to do it in a modular way where we don't have to hard code a bunch of stuff. So DLA symmetry none, and we'll probably do, okay, it's apply paint now, so a little bit different. Oh my goodness. There we go. So we'll apply paint. If we want horizontal symmetry, then center X. And if X equals center X, self.apply paint. Why can't I type that one? So we'll apply it and do nothing else. Or we get the distance from the center to wherever we're at, and we apply paint twice. Did it again. So we're applying it in two different places. One, some distance from the left of the center, and one some distance from the right of the center. And that's about it for that one. I'm going to guess vertical symmetry is going to be identical, except we replace x's with y's. So let's give that a try. It only makes sense, right? This one will be a little bit different. So it'll be x, and then it'll be center y plus dist y. And then this will be x center y plus, minus dist y. Doesn't really matter which order we do those in. And instead of this, it'll be center y minus y. And then we'll rename this to dist y. I made it mad. I didn't mean to save yet. But yeah, that should be it. So then here, if y is center y, oh, we need to change the, yeah, we need to change this to height, of course. So if y is center y, we just paint it. Otherwise, we get the distance, center y minus y. And then we apply on x. Ooh, yeah, I missed one there. We apply on x. So we do center y plus dist y and center y minus dist y, and that's it. And then symmetry of both. Well, you might be able to guess about how it's going to look. Center x equals self.map.width. And center y, height. And they're both divided by 2. I've done something like this at my last job, where I needed to flip things around a center point. And I did it horizontally, vertically, and both. So this is very similar to something I've done before. I think apply paint is going to be the function that we had. Oh no, it's actually going to be a little bit beefier. Okay, so we're not going to bother with it yet. I was wondering, can I go ahead and implement that? Oh, we'll hold off. So if it is center x and center y, then we just paint. Otherwise, we have to do the distances. So we'll get our center x. You know what? I'm going to copy these because they're the same. And then this is also the same. So we get our distance x from center x minus x, absolute value. And then we do center x plus dist x and y, center x minus dist x and y. And then we do the same thing with dist y, where we do center y plus dist y and center y minus dist y. So it's the same stuff there. So we'll look at the tutorial text here. It's a longer function than it really needs to be. In the name of clarity, here's how it works. We match on the current symmetry setting. If it's none, we simply call apply paint with the destination tile. If it's horizontal, we check to see if we are on the tile. If we are, just apply the paint once. Otherwise, obtain the horizontal distance from the center. Paint at center x minus distance and center x plus distance to paint symmetrically on the x-axis. If it's vertical, then we basically do the same thing. We check to see if we're on the tile. If we are, we just apply paint. It also says this helps with odd numbers of tiles by reducing rounding issues. Cool. Otherwise, obtain the vertical distance from the center. Paint at center y, distance y, and center y plus dist y. And then if it's both, then we just do both. It's easy. And then we're calling apply paint rather than actually painting. That's because we've also implemented brush size. So we'll take a look at it. Let's get down here and do apply paint. Now all that other stuff will get happy even though we're not doing anything yet. It's a lot nicer. So let's go. So we'll convert that X and Y to a map index. I forgot the match part of the block. I'm like, wait a minute. I was like, wait, what are we matching on? All right, so this one's pretty easy. Because it's basically what we had before. We just convert that index and then we print it. Or we convert it to floor. Now, this is getting a little mad because, and it's raising a good point. Unless we're doing things with specific brush sizes, we might convert this from a match to a conditional. I like matches. I have a tendency to want to overuse them, but I think this is a case where it might be better to do an if. It's an unnecessary syntax. If it's one, we do this, else we do something else. But we'll convert it later. Let half brush size equal self dot brush size over 2. So what we're doing is for brush Y in Y minus half the brush size to Y plus half the brush size. So we're treating Y as the center there, brush Y as, or, you know, we're treating Y as the center there, correct? And then we're going to do the same for X. For brush X in X minus half brush size to X plus half brush size. If brush X is greater than 1 and brush X is less than self dot map dot width minus 1 and brush Y is greater than 1 and brush Y is less than self dot map dot height minus 1. That should be it. Oh no. These things are freezing up on me again when I'm scrolling. Just wanted to make sure. Then we'll do let idx equal self.map.xy index. Use brush X and Y. So basically we just paint multiple things, multiple tiles. We do this loop over all the points in the brush and we turn them into floor. And now Clippy's not mad. I guess it's because we put some stuff here. I still say we could do it with just a simple conditional. Clippy's not mad though, so whatever. We'll keep going. I mean, the general idea though is basically if self brush size equal 1, else, and that's it. Okay. So the tutorial text says this is quite simple. If brush size is 1, we just paint a floor tile. We have here. Otherwise, we loop through the brush size and paint, performing bounds checking to ensure we aren't painting off the map. Your constructor uses central attractor and enable symmetry with horizontal. All right, let's check it out. Still going to be very slow. And it says, you get a map not unlike a cranky insectoid. Yeah, very much like some Space Invaders kind of stuff, like they were saying. Looks cool. I like it. So now we're also going to play with brush sizes. So using a larger brush ensures that you don't get too many one by one areas that can be fiddly to navigate, and it gives a more planned look to the map. Now that we've already implemented brush size, modify your constructor. So we're going to change it to a brush size of 2. And actually there's some other stuff here. We're doing walk inwards and no symmetry. I'm going to be a little lazy. Yeah, it should go a little bit faster now just because it's going to be quicker to... Oh, that was a good pop. That was my finger. It should be quicker to uncover that map, but it's still not great. I feel like I'm doing an extra snapshot and I'm just not seeing where it was. Like I must be taking a snapshot extra times through the loop or something. Except I'm not. I take one at the end of each loop after we run this. I feel like it would almost make sense to track how many times we do something. Track our iterations and then do this only once every 10 or 20 or 50 or something. Maybe once every like 10 or so. I don't know, I just feel like it's really slow. Unbearably so. Alright, but we got a bit of a change in looks there, and we can take a look at the page here and see it. There's running much faster. We're going to provide a few constructors. Rather than pollute the random builder function with algorithm details, we'll make constructors for each of the major algorithms we used in this chapter. So, basic constructors here. I don't feel like typing 4 of those out. They're all the same. I don't think this is a case where we have anything to prove by, or anything to learn by making 4 different constructors like that, right? So we'll just go ahead and plop those in here. And then we will update our map builder as usual. So now I can call any of those. And if we run this a couple times, we should, with relative frequency, get one of the new ones, because there are 4 out of 12 options. Yep, there we go. Now, I'm going to take another quick look at their code. I almost want to just try copying over the build, because I didn't really change anything. I'm going to try that first, just a really lazy, let me copy the build function over mine. And see if it's faster when we get it running. No, it's still slow. So I don't know if they just sped up the generation on their end or what. So I think I'm going to add a little bit of flavor in here, which is going to be before we go into the loop. Let's see. Yeah, the snapshot happens in there. So before we go into the loop, we're just going to say let mute counter equals 0. And then we'll say counter plus equal 1 if counter mod 10, then take a snapshot. Should be much faster now. Yep, that's it. It's actually viewable. That really hollows out the interior, though. I don't know if I like how much that ends up hollowing out the interior. This one's always cool. This is the one I was hoping to see. With a little bit of speed there. So we can begin the game. And we have items as we expect. Heal up. Step on that trap. All right. Pretty cool. That's really it. Hopefully that speed up makes things a little more viewable there. But yeah, I don't think I made any mistakes there. When I copied their code in exactly, should be identical. I don't think I made any mistakes. It was still really slow, so they must have sped up the generation on the animations that we see here on the page. I guess that's it. In one of the previous ones, we actually went through and did that boilerplate in the maze. We did that not boilerplate, but we did that code to speed things up. I'm a little bit surprised that we didn't do that here, that it wasn't part of the tutorial. And it's not even in the text here, which is what was odd. We just take snapshot right after the match, right before the floor tile count. How strange. Okay. Well, we randomized the map builder. We're all happy there. And this chapter has introduced another very flexible map builder for your arsenal. Great for making maps that feel like they were carved from the rock or hewn from the forest, mined from the asteroid, etc. It's another great way to introduce variety into your game. And now we're going to look into this refactor. Let's just scroll all the way up. Let's look at our scroll bar here. It got a lot larger. It almost doubled. That's good. It's nice if we're going to do more than one and this is just a refactor. It's nice that we won't be spending like a crazy amount of time on it. But it'll be good to get this over with because that'll prepare us for another map next time rather than starting with a refactor. So in the previous, this is just adding symmetry and brush size as library functions. So instead of tying it to the algorithm itself, if other algorithms are going to be using it, I guess, then this is what it's for. By the way, wave function collapse, I'm really looking forward to. I mentioned a video called why I'm using wave function collapse to generate my, or whatever. If you type that much in, you'll probably find it, why I'm using wave function collapse. But basically, there's all these algorithms. We haven't seen anything about it here, and I don't think we will. But you see these algorithms when it comes to generating things like voxel terrain, voxels like Minecraft or whatever. You see things called like marching cubes and stuff, and it can produce some okay results, but wave function collapse can work in like 2D or 3D as far as I understand. But what you kind of do is you set like pre-built tiles and stuff, and you make like an adjacency matrix or whatever. So an example is water is a tile type, and then the only thing that can go next to water is maybe sand. And then sand can go next to water or grass. So you can imagine you go from the water to the sand to the grass. So sand is valid to go between grass and water. So then grass can go next to sand. It can go next to trees. It can go next to all kind. Maybe grass has other options. But basically what you do is then you pick like a random tile and you set it to something. You set, okay, this random tile is now sand. So then what you do is all the adjacent tiles to sand, you then get to set them, or you get to reduce their domain space, because now that you've put sand there, all the adjacent tiles to it can only be water or grass. So then instead of having like 10 options or however many tile types you have, well, now all those adjacent tiles only have 2 possible options. So that reduces the domain space. And this is kind of the idea of like collapsing, I guess. This is kind of the idea of like collapsing down into like a finalized map. And so it's really interesting. That video was pretty cool to watch. There's a part 2 of the video that gets more in depth, I believe. But I haven't watched that one yet. But just the thoughts on it. So I'm really interested in seeing that, because I've already peeked at it in previous sections, and we see they're making tiles here. They have the Rex painter, and they were making tiles and stuff. So I think we're getting into those same ideas here. We're going to be defining, well, these things can go next to each other. See, this is the chunks of the map. And then we're going to be defining a set of rules, and those rules kind of build out our maps, which is really cool. So I'm really looking forward to that. It is maybe how a game like Noita does its map generation, because Noita uses prefab pieces, little chunks of tiles that are repeatable. And if you play the game enough, you start to recognize some of those patterns, but the way they get pieced together is different every time. So that's why I think it's going to be really cool to get some experience with that algorithm. But that's a big aside, because we should be doing this brush size thing. And then I'm also excited because Voronoi Hive maps look cool. So I don't want to discredit that. But I'm just really excited about that, and I could not hold in the excitement. All right, enough of that aside. Let's not waste any more time. Let's get right to adding symmetry and brush size as library functions. So in the previous chapter on Diffusion-Limited aggregation, we introduced 2 new concepts for map building: symmetry and brush size. These readily apply to other algorithms, so we're going to take a moment to move them into library functions. So we're going to go to common.rs in our map builders. We're going to make them generic and demonstrate how they can alter the drunkard's walk. So we're going to build the library versions already. You know, I love it. Let's go to common. Actually, how do I do this here? There. Okay. We'll start by moving the DLA symmetry enumeration out of DLA and into common. We'll also change its name since we're no longer binding it to a specific algorithm. So DLA symmetry, you're gone. That's going to make it mad, but that's fine. And we're going to put this here at the top, and we're going to rename it to symmetry. And none, horizontal, vertical, or both. All that is good. So at the end of common.rs, we're going to add the following, which is a paint function. So let's take a look at that. I'm trying to see how much I can copy. So we're going to take our map, immutable reference to our map. We're going to take a mode, which is the symmetry, a brush size, I32, X, and Y. We're going to match the mode. And I'm going to be a little risky here and just copy this. and change the names. And we're going to have to modify a few things, right? We're going to need apply paint here as well. So we actually do use apply paint. So pub fn apply paint. Brush size I32, X, I32, Y, I32. And it's going to be very similar to what we've done over here though. So again, I'm going to just be a little ballsy and copy this thing. And we'll modify as needed because it is very similar. I know, we can't let all these selfs continue to exist in here. Map.tiles, brush size, map. I will do the proper comparisons, but I mean, this is how things go. Refactoring is typically a lot of copy paste, right? Copy and modify, remove specific references and make them more generic. And with modern IDEs, look for where it's mad, right? Even with modern like Vim or like NeoVim or Lunar Vim or all these different Vims, look for where it's mad. So you're gonna have to change all of the apply paints, which is gonna be a little fun, but I think it's not gonna be the worst. So the first apply paint is gonna be map, brush. Ooh, I got an idea. I do have an idea. We're gonna go up here and cool. We made all of those happy, I hope. Beautiful. Alrighty. That's a proper refactor right there. Oops. I think I did something goofy here. What did I do? I did a comma. All right. So let me just double check. Symmetry mode, none. We apply paint, map, brush size X, Y. Beautiful. Under horizontal, we do the center X, map width over 2. Beautiful. If X is center X, we apply paint, map, brush size X, Y. Else, let dist X, and we do all that fun stuff. Ooh. There's no else here. That was goofy. I must have missed that earlier, but we didn't test all of these symmetries. So it was fine, I guess. Well, my bad. We caught an issue. Oops. Yeah, we caught an issue, but that doesn't matter anymore because we're getting rid of it. Good to know, however. Vertical, both. So if X is center X, we apply paint, map brush size X, Y. We do absolute value, center X minus X. Yep, it's all the same, right? I don't think we need to look anymore. I think everything is going to be fine. Alrighty, so now the tutorial text says this shouldn't be a surprise. It's the exact same code we had in DLA.rs, but with the mute self removed and instead taking parameters. So now we're going to modify DLA.rs to use it. Come back over here, and it's relatively simple to modify. It's relatively simple to modify DLA.rs to use it. Replace all DL. Actually, yeah, we can look for DLA. That's a pretty safe replace all, I think. So replace all DLA symmetry with symmetry. Replace all calls to self.paint XY So self.paint, there's another way we're going to do it. So we'll look for this. Self.paint, it's going to be paint. It's going to be mute self.map, self.symmetry, and then we'll leave the others in place. Yoink, yoink, yoink. I thought we basically pulled in all of common here. You know what I need to do maybe is I'm in the wrong place. Common star. They're common for a reason. I know we won't use all of them, but let's be lazy about it. Paint takes 5. Why do you take 5? Oh, they take the brush size. Oops, I missed the brush size. No, we're good. We'll just keep being lazy about it. Copy all of that. Control H. And then we'll add self.brush size. If I did that right, we're good. Okay. So replace all DLA symmetry with symmetry, replace all self.paint with paint, and then we do mutable reference to self.map, or not a reference, but self.symmetry and self.brush size, and then we keep passing in the X's and Y's that we were passing in before. I think 2 of them are prev X and Y, and 1 of them is just X and Y. That's why I wanted to be lazy about it. And that's why the way I did my find and replace, I didn't replace the ending part here. I only replaced the beginning part. You could check the source code to see the changes. No need to repeat them all here. Make sure to include paint and symmetry in the list of included functions at the top 2. Yeah, I just included everything because I'm lazy. Like a lot of refactoring, the proof of the pudding is that if you cargo run your code, nothing has changed. We won't bother with a screenshot to show that it's the same as last time. Let's take a look at it. What are the odds it gives me a maze? I'd say about 1 in 12. I think that one's my favorite, the regular drunkard's walk. Okay, here we are. Moving at a respectable pace. Much better when I added that check in there to only snapshot it out of every 10 loops, every 10 iterations. I want to get the mosquito or the insectoid one. I think that one's my favorite variant of this. This does look really cool, though. This one I quite like. Come on, give me an insectoid. Don't make me... Don't make me go force it, because I will. It almost looks like flowing water filling something in a little bit, but is not. Let's check out insectoid here. There we are. The lack of those else's might have messed up some of my symmetry. I didn't really pay that much attention to it, but that's why I wanted to just double check and see how those look. So we no longer need apply paint. And we no longer need paint here in DLA. So that's good. And anything else going on in DLA? DLA is really happy. Not a single thing is lighting it up right now. These vertical and both are never constructed, but that doesn't mean we won't construct them at some point. Regular Drunkard's Walk Builder is not used anymore, but actually we should probably get rid of it. We'll just hang on to it. It's fine. I hate the unused thing. I know we can suppress it, but it's still unused. Suppressing it doesn't make it used, right? It just ignores that. Okay, so we're going to modify Drunkard's Walk to now use the common library stuff here for painting and all that. So let's go to drunkard.rs, and we're actually modifying Drunkard's settings, so that's perfect. Drunkard settings, spawn mode, drunken lifetime, and floor percent is all going to be identical, but we're going to need a brush size, I32, and a pub symmetry. I don't know how much I'm going to like necessarily making this symmetrical. I hope we do variations, kind of. We'll see. Cannot find symmetry. What do you mean? What are you doing? What do you mean? Import, and it doesn't. We could qualify. I wonder why it wouldn't import. That was odd. Alrighty, so we're going to go to open area, and in our settings, we're going to do brush size 1, symmetry none. We're going to need to make similar changes to the other constructors, just adding brush size and symmetry. So I'm going to assume we just add the same ones, like this. We'll just go to floor percent, plop these on at the end. And there we go. We also need to replace the line self.map.tiles, tile type downstairs. This one here. So we're no longer going to be putting downstairs everywhere. So it's going to be paint. Brush size, drunk X, drunk Y. That's all we need for that. Drunk index equal tile type downstairs. So we're still doing it. We really just moved it. Fine. The double draw retains the function of adding the floor symbols to show you the walker's path while retaining the overdraw of the paint function. And now we're going to make a wider carving. That's what the text says, by the way. So where I just did that replacement, just to be clear, on the downstairs stuff, this here. So we paint it, then we do the downstairs. That's the double draw. So it's still retaining the function of adding the stairs symbols as well. That's the idea. While also taking advantage of the brush size thing. That's the way I'm understanding this. So now we're going to make a wider carving drunk. To test this, we'll add a new constructor called Fat Passages. Drunkard's Walk Builder. We'll make a builder. It's going to be map, new depth. Do I really need to do this? Depth, new depth, history, a new vec, noise areas, a new map, a new hash map. Drunkard settings, save that. So it'll format my save auto formats. So spawn mode, drunk spawn mode, random, lifetime 100, floor percent 0.4, brush size 2, symmetry none. That's our fat passages. And we'll quickly modify random builder to use it. Bet you can't guess how this one's gonna go. Oh my goodness, we're not being random. So you can see the parts that are actually being that are being carved out are not his path, right? It's only a few like carrots, right carrots or greater than symbols or whatever. It's only a few of those that are appearing, but what's being carved out is much greater. And that's because the fat passages, right? The brush size. So we could actually make that even larger if we wanted. We could do a brush size of 3, and it's going to just like open this thing up quick. It's already opening it up quick. Maybe not as quick as I thought. 6. See, look at that one. They barely had to do anything. Alrighty, we'll go back to 2, a more realistic number, and take a look here at the browser. This shows an immediate change in map generation. Yeah, pretty straightforward. Notice how the fatter digging area gives more open halls. It also runs in half the time since we exhaust the desired floor count much more quickly. So now we're going to add symmetry. Like DLA, symmetrical drunkards can make interesting looking maps. We'll add one more constructor. Now I am going to copy this one. It's called Fearful Symmetry. Interesting name. I'm going to copy this one. We'll just read over what it's doing. New map, new starting position 0, new depth. History is a new vec. Noise areas is a new hash map. And the settings consist of a random spawn mode, drunken lifetime of 100, floor percent of 0.4, brush size of 1, and symmetry of both. And we'll modify random builder to use it. I am too lazy to even change that. So we're just going to copy this in here. And let's take a look at it. So if we did everything right, then this should just be nice and symmetrical for us. Yeah, oh yeah, it does. Cool. I felt like there were some areas that didn't come off as symmetrical as I would have expected, though. I feel like it's not perfectly symmetrical. And that's something that I saw earlier. Well, that's happening on theirs as well. which is kind of interesting. I'll have to dig into that a little bit more, no pun intended. I'll have to dig into that more to completely understand why it seems like there are a few places that aren't perfectly... Oh, no, right. It is, but it's diagonal symmetry. Is that what's happening? No, we'll have to think about it maybe. And what I have looks fine. It looks like what they have, but we'll take a look at it in just a moment. We're gonna restore randomness once more, and we're basically done. We're in the wrap up section now, so we can take a look at their example, and I'll try to point out what I'm describing with the symmetry being interesting. So symmetry is applied really fast. We're blasting out the floor tiles now. Unreachable areas are culled, getting rid of part of the map. It's quite a nice map. We'll take a look at it in a moment. So the random builder, straightforward. We have 14 algorithms, an increasingly varied game. And this chapter has demonstrated a very useful tool for the game programmer, finding a handy algorithm, making it generic, and using it in other parts of your code. It's rare to guess exactly what you need up front, and there's a lot to be said for you won't need it, implementing things when you do need them. So it's a valuable weapon in our arsenal to be able to quickly refactor our code for reuse. Now let's take a look here at what I mean. It looks like everything starts out really symmetrical, but here I'm seeing pieces like this section here, right there. See when that gets added? It gets added at the bottom as well. There's a match. It gets added over here, boom, but it's not getting added on the top part here. See that it never appears when it appears in the other three areas. And I find that odd because it's really hard to point out exact things on the map. You know what I think it is? Hold on. See this little construct here, this little room thing here? It appears in the bottom right and it appears in the top right here, but I never see it appear up here. I think there's one case of symmetry that's missing. I think one of the cases of symmetry is not properly implemented, and that's why we're not getting stuff to appear on the top right, because two of the cases I pointed out where we see constructs appearing only seem to they appear in the other three quadrants, but not over this way. I might go bug hunting because I'm intrigued by this, but maybe that's how it's intended to. I don't think it is. I'm a little bit interested and intrigued by that, but now's not the time. I'm not going to do it on stream. I'm going to wrap up, and we're going to do Voronoi Hive maps next time, which are going to be really cool. We've seen how they look. I like the way this looks. It's very, very open, but I like the overall structure of the map. You could do this for some like very insectoid things. How do they describe it at the top? It's a bit like a hive, exactly. You'd even probably tweak it a bit and it'll be like a web or something. So I really like the look of that. So yeah, we're gonna call it there. We got through the Diffusion-Limited aggregation, which was very easy. Not really much to it. This one's gonna be very easy. So we'll probably have a very quick session for Voronoi Hive maps. I'm just gonna do one session there. I'm not going to, uh-oh, froze up a bit. There we go. I don't know why that started happening. I'll probably just do one session there for Voronoi Hive maps, even though it's very quick, because wave function collapse is very long. It's the longest section we've done in quite a while. I don't know if any of our map sections have been that long. Refactoring map buildings was not that long. Binary space partitioning was not that, yeah. No map section has been that long yet. Magic mapping, traps, particle effects, blood stains, nice walls. That one's really quick. Equipment, difficulty, delving deeper, saving and loading. So far, nothing has been that long. Items and inventory is not even that long. Dealing damage, monsters, field of view. Okay, yeah, so we're in for a real big boy there. Entities and component. Yeah, that's the longest section we've seen so far, wave function collapse. So as much as I'm excited about it, we're going to have a really short session for Voronoi Hive maps, or Voronoi Hive / cell maps. And then wave function is going to be a big old beefy boy that we're going to have to hammer out in one session. But I think it'll be fun. I think it's because we're having to do the tiles and everything in the same session, so it might be a little quicker than I'm thinking, because there's a lot of images there of like graphics and stuff that might just pad that a little bit. All right, so that's enough. So thank you to anyone who shut up, whether you're lurking, chatting. I really appreciate it. If you like this kind of stuff, you want to see more coding streams, or you want to see some gameplay streams, hit that follow button here on Twitch. You can also go on over to YouTube, or if you're watching this in the future on YouTube, congrats on being in the future. And you do all the fun YouTube stuff. Like, subscribe, notification bell, leave a comment. I do read my comments and I try to respond. And I stream quite a bit, almost every day, maybe every day. It depends. I'm getting back in the swing of things. I had a pretty rough go of it for a few weeks, but it's getting a little better now, sort of. So should be streaming quite a bit. Dwarf Fortress exists now. Dwarf Fortress Steam exists now, so I'm pretty happy about that. Really enjoying it. You can also follow me on Twitter if you want to see when I go live. I do tweet every time I go live, so there is that. And then I tweet lots of like adorable foxes and stuff, because why not? I think that's about it for the outro. Pretty simple, pretty quick stuff. I don't want to dwell too long on any of this. So until next time when we tackle the Voronoi Hive maps, have a good day, have a good night, whatever it is, wherever you're at. Take it easy.
Oh no,